Alright, so this video covers question 6 on homework 6.1, and the question asks you to find the antiderivative of x squared times e to the 4x, antiderivative x squared e raised to the 4x dx, and we're going to use integration by parts. So when using integration by parts, the formula for that is going to be uv minus the antiderivative of v du equals the antiderivative of u dv. So what this big formula here means is we need to pick a part of the function, and we're going to let that be u, and we're going to take another part of the function and let that be equal to dv. So generally, in picking your dv, you want to choose something you can very easily anti-differentiate, which in this case would be e to the 4x. And then for our u, we're going to let that equal x squared. So then you try to find your du, which is 2x dx, and our v, there should be a dx right there, because that's a differential. We should come out with 1/4 e to the 4x. You can put a plus c there, but we understand that this is going to be an antiderivative. Okay, so we can plug in back into our formula right here, and we're going to say the antiderivative of x squared times e to the 4x dx is going to equal u times v, so that's 1/4 x squared e to the 4x minus the antiderivative of 1/4 e to the 4x times 2x. Okay, so we simplify a little bit, and we come out with 1/4 x squared e to the 4x minus, well, we know that 2 times 1/4 is a half, and we get x e to the 4x dx. Sorry, that should be up here as well too. Okay, and there's no rule against not using integration by parts more than once. We can certainly do that so long as we keep track of what our u's and v's are. So we can ignore the rest up here, right? We already used these u's, v's, and du's, and we can say that we're trying to find this antiderivative right here. So we'll set up a new chart where we have a new u and a new dv. And we go through the same process again, in which e to the 4x is going to be our dv, that's easy to anti-differentiate. And then we have x as our u. So then our du is going to be 1 dx, and then our v is going to be 1/4 e to the 4x dx. Don't forget we have a 1/2 outside of here as well, so we can't let that disappear. And what we're left with is 1/4 x squared e to the 4x minus u times v, which is going to be x 1/4 e to the 4x. And don't forget, we have that 1/2 out here still. So here's 1/4 e to the 4x, and we'll put the x out here, right, u times v. And then we're going to subtract the antiderivative of v, right, I'm just going to pull that 1/4 out again, and it's going to be times du, so e to the 4x. du is just 1 dx, so we can just put that in there like this. That whole quantity is going to be multiplied by 1/2 because we had that 1/2 outside beforehand. And again, we're left with 1/4 x squared e to the 4x minus, let's distribute that 1/2 in, 1/8 x e to the 4x minus 1/8 the antiderivative of e to the 4x dx. Okay, I'm just going to erase a little bit of stuff up here if that's okay. Okay. And going back up here, excuse me. We come out with 1/4 x squared e to the 4x minus 1/8 x e to the 4x minus, we know this antiderivative, it's just 1/4 e to the 4x, but we have a 1/8 on the outside. And this is also going to be a plus sign because we're going to distribute the negative in. Plus 1/32 e to the 4x plus a constant is the answer that we should get to. So in summary, what we ended up doing here was we used integration by parts once, we used integration by parts again, and because we did that, we were able to come up with a third integral that was much easier to anti-differentiate. It's just a couple of different steps. So I hope the video helped out a little bit on your question, and if you have any more, just feel free to post it on Sakai again. Thanks a lot.